So this is 6.2, a binomial distribution. A binomial distribution is a particular type of probability distribution, and it's produced from a binomial experiment. But for it to be a binomial experiment, it has to meet 4 conditions. And these are the 4 conditions. So let's look down here. Are they binomial? Counting how many cards you draw until you get a club. Well, if you're counting until you get a club, there's not a fixed number of trials. So this is not binomial because there's not a fixed number of trials. Selecting a Democrat, a Republican, or an Independent out of a phone book. Well, if you select one, it's not 2 outcomes. You would either get a Democrat, a Republican, or an Independent. So because there's more than 2 outcomes, then it's not binomial experiment. Number of correctly guessed answers on a 10-question quiz, with the first 5 true/false and the second 5 4-part multiple choice. Well, it has a fixed number of trials, which would be 10 questions, so 10. The trials are independent, and they are. One doesn't have anything to do with the other. The same thing with the cards. It was independent. One card doesn't have anything to do with the next card that you draw. Selecting a Democrat, Republican, or Independent, because you're picking one at a time. So back to 3. It passed 1, it passed 2. Each trial must have only 2 outcomes, success or failure. You either get the question right or you get the question wrong. So far, it's a binomial experiment. But the probability of success in each trial, so trial 1, which would be question 1, would be true/false. That's 50%. Question 2 would be true/false, 50%. So the first 5 would be true/false, 50%. But when we look to the second 5, we see that this is a 4-part multiple choice. So in this case, you have 25% chance of, you have 1 out of 4 chances, which is 25% chance of getting it right. Here you have half or 50% chance. Since our probabilities are not constant, it's not a binomial experiment. So it has to pass all 4 of these all 4 of these things for it to be a binomial experiment, for us to be able to do a binomial distribution on it. So to calculate a binomial distribution, or calculating binomial probabilities, where x equals the number of successes, if n equals the total experiment, if we then say n minus x, we have found the failures. The number of failures. Well, if Q stands for the probability of failures, how can we find Q? What would Q equal? It would equal 1 minus the probability of successes, which is P. So 1 minus P would equal Q. To find the probability of X successes in N trials, so when you see to do this, this is a formula that you're going to use to set up the probability distribution. And my screen is out of whack.
This is the life for a rebel. Sorry.
Okay, I figured out how to fix my screen. So this is the formula to set up the probability distribution. And then this is the formula to find the mean. This is the formula to find the standard deviation.
Make more combos. There you go.
Okay, here is an example. It says the geneticists determine a couple has an 80% chance of having a green-eyed child. If they plan to have 5 kids, explain how this meets the 4 conditions of a binomial experiment. So the first condition is there has to be a fixed number of trials. Well, since they plan to have 5 kids, it would be a fixed number of trials, 5. The trials must be independent of each other. Well, having one child has nothing to do with having the next child. Each trial must have only 2 outcomes. You have a green-eyed child, or you don't have a green-eyed child. So 2 outcomes. The probability of success in each trial must remain constant. Well, each time you have a child, you have 80% chance of having a green-eyed child. So that's constant the whole way through. So then it asks us, what is n? N is the number of trials, and we said that would be 5. P is the probability of success, which would be 0.8. Remember, Q is 1 minus P, so that's going to be 0.2. And the formula would be 5. And since this is what we're looking at, choose X, which would then be 0.8 to the X power, because we don't know what it is, times 0.2 times N minus X. And so now we're going to create the probability distribution using this formula. So we could have 0 green-eyed children, we could have 1, we could have 2, we could have 3, we could have 4, we could have 5 green-eyed children. What is the probability of having 0 green-eyed children? Well, we have to use this formula right here, which would be 5, choose 0, times 0.8 to the 0 power, times 0.2, times n, which is 5, minus x, which is 0. So that's to the 0, which would be 5. Put this into the calculator, and it will give you this. So now I'm going to tell you how to put this into the calculator. I can't show you the calculator, but if you listen carefully, you'll be able to follow me. And if not, just rewind and you'll be able to follow. So you're going to put the number 5 in first. And then you're going to press Math. So this is a button you're going to press. This is a button you're going to press. Now you're going to press the arrow button to the left, which should be on top of PRB. And on top of PRB, you should see number 3, you should see this C thing. So press enter, or press 3 or press enter, either one. And so you should see, now you're going to put in the 0. So on your screen, you should see 5 N C R and then a 0. If that's not what you see, then you will see a box with the 5, the C, and a box with the R, which is 0. Now let's put in the rest of the problem. Right here. Which would be parenthesis, 0.8, parenthesis, raised to the 0 power, and 0.2, parenthesis, raised to the 5th power. And what I see is 3.2 e to the negative 4. Well, this negative means that this has to go over 4 places. So that's going to give us 1 place, which is the 3, and then 3 more zeros, which that's so close to 0, we just use a 0 with the plus sign. Okay, I'm going to clear this screen off. And and this was 0. 2, 5. So we find this to be 0 with the little plus sign. So now we're going to do 1, which means we're going to put 1 here in place of x, which is going to be, excuse me, which is going to be 5C1, and then 0.8 to the 1st power, and 0.2 to n minus x, which is 5 minus 1, which would be to the 4th power. These right here, I'm pointing to the 1, and I'm pointing to the 4. These right here will always add up to n. Okay, so when you put that in your calculator, you get 0.01, and then you do it with the 2 and you get 0.05. You do it to the 3 and you get 0.20. The 4 gives you 0.41, and the 5 gives you 0.33. Okay, so I'm going to clear the screen because you can't see what I'm going to do. Alright, if this family has 5... Whoa. I don't know what happened there. If this family had 5 children, then what is the expected number of green-eyed children? What are you really... What are you really finding? Well, the E is the expected value, which is the same as the mean. And the mean is N times P, and N was 5, and P was 0.8. So E equals